Fusion Mobile, quality e-learning experience on the go.
My lovely one out there, welcome to today's topic, simple harmonic motion. Can you remember that if a small body or a particle vibrates or moves to and fro along a straight line under the influence of a force, so that its acceleration towards a fixed point or its equilibrium position is proportional to its distance or displacement from that point, this particular system or the body is said to perform a kind of motion known as simple harmonic motion. Example: mass on a spring and your daily simple pendulum you use. So we can say that simple harmonic motion is the motion of a body whose acceleration is directed towards a fixed point, and this acceleration must be proportional to the displacement from that fixed point. If I use our simple pendulum for example, when it moves through to this point, at a time it goes back through to this point. We now say that here is a fixed point, that when this particular body here moves on this point, the acceleration of this body is directed towards this particular fixed point, and this kind of acceleration or this kind of system which has the acceleration directed towards a fixed point is known as simple harmonic motion. We can now discuss parameters that we can use to study simple harmonic motion. The first one is the period. But before we talk about period, I want us to talk about the basic ones, like the cycle. Cycle simply means the complete to and fro movement of a body undergoing simple harmonic motion. The complete to and fro movement. When you have a complete to and fro movement, we say that you have completed one cycle. Amplitude. This is the highest displacement made by the body undergoing simple harmonic motion. We can now come down to period. As it is on the slide, is the time required to make one complete revolution or cycle about a point of reference. Mathematically, it is given as T equal to time over number of cycles. Period is equal to time over number of cycles. Frequency, F, is the number of complete revolutions per minute. Mathematically, it is given as frequency F equal to number of cycles over time taken, and the SI unit of frequency is Hertz. We talk about amplitude, which I've mentioned before. It is defined as the maximum displacement of the body from equilibrium position. Now, discussing further on frequency and period. Since frequency is equal to N over T and T equal to T over N, mathematically it is obvious that F is equal to 1 over period and period is equal to 1 over F. We can discuss further on linear distance. Let's talk about angular distance first. Angular distance is the angular difference. The angular difference created by the body undergoing simple harmonic motion. While linear distance is the linear difference. This one where my hand, or it can be measured on the circumference, is the linear difference made by the body undergoing simple harmonic motion, and both are related. We can say that linear distance d is equal to r theta, while some people conventionally represent it with s. So we can say that s is equal to r theta, where s is the linear distance, while theta is the angular distance, and r is the amplitude of the particular body we are discussing. So we can talk about angular speed and linear speed. Talking about angular speed, this is the rate of change of angular distance with respect to time. That means angular speed mathematically is giving us omega equal to theta all over time. This is angular speed. Omega equal to theta over time, where theta is the distance and t is the time. While linear distance s, or linear speed v, is equal to linear distance s all over time. But initially we'll say that linear distance is equal to r theta. That means that v is equal to r theta all over time, and theta over t is equal to omega, so v is equal to r omega. Again, v is the linear velocity, while omega is the angular velocity. We can move further to discuss about angular acceleration. In angular acceleration, conventionally is represented as alpha, and alpha is change in omega all over time, while linear acceleration a is equal to r alpha. My dearest, I would like you to work out for us the proof that a is equal to r alpha using this particular equation. Okay, I would like to discuss about resonance. Resonance in simple harmonic motion is a vibration set up in a body due to a transfer of energy from another body which is vibrating with a period of frequency the same or nearly the same as that of the first. It can also be said to be a phenomenon which occurs whenever a particular body or system is set in oscillation at its own natural frequency as a result of impulse or signals received from some other systems or body which is vibrating with the same frequency. Furthermore, I would like to place the equation of period when we are discussing simple harmonic motion, which says that t is equal to 2 pi square root of L all over G. T equal to 2 pi all over 2 pi square root of L all over G. For a spiral spring, T equal to 2 pi square root of M all over K, where K is the spring constant. I would like you to make a detailed study of all these equations. Go back to them one by one, starting from x equal to r theta, v equal to r omega, and a equal to r alpha for distance, velocity, and acceleration. When you are through, join me in the next topic, which is Newtonian motion. See you there.